Hello and welcome back to another episode of Math with Sound. Today we're going to be dealing with friction involving pulleys that are on some surfaces. So the first one is going to be on a flat table surface, and then the next one is going to be on an incline. Okay? So if you have a pulley on a surface, the first thing you need to figure out is this object going to actually be moving? And if they don't give you the static coefficient, you can pretty much assume that it is moving, or it will tell you. In this case, we have a 3 kilogram block being kind of like moving down towards the earth, and it's being slowed down and dragged down by this 2 kilogram block that's saying, no, I don't want to move. And that 2 kilogram block is having friction opposing it, and that friction is 0.3 for the coefficient of friction there. What is the acceleration of the blocks? Notice how they say the blocks? They don't say what's the acceleration of this 3 kilogram and what's the acceleration of this 2 kilogram. They're both moving together in unison. This one's going down and this one's going over. So you can think of it in the X and Y direction, but really it's no different than if you were pulling this completely straight outward, the 3 kilogram one, with the same effect that gravity would be at like 10 meters per second squared. Okay? So what I'm going to do is I'm going to start by recognizing that we have a situation where the sum of all forces in the system would be equal to its mass and its acceleration. Okay? Now it will be moving down with this 3 kilograms times 10, which is the mass times acceleration of this. So this downward part, that is going to equal 3 times 10 meters per second squared. I'm rounding for 10 instead of using 9.8 meters per second squared. If you have to use 9.8, please do. So that would be 3 times 10 meters per second squared. But we have to take away this guy. And what is that guy doing? That one's slowing it down, and it's slowing it down due to friction, and friction is the friction coefficient times its mass times its acceleration. So this would be the friction coefficient, 0.3, times its mass, 2, times gravity, which would be 10. That would be the normal force because the normal force is going straight up from the table there. So we have to take that away because that is slowing this block down. If it weren't for friction, this would go whew, straight down the table. Okay? So we have to subtract the 0.3 times 2 times 10 from that. And when we do that, we would end up with a total force of the system of equaling, let's see, I think it's 24. 3 times 30 times, yeah, this is 30 minus 6, which ends up being 24. So 24 is the total force of the system. Is that what is being asked? It wants to know what is the acceleration of the blocks. Well, no. This is the total force of the system. Well, force of the system is equal to mass times acceleration. And what is the mass of the system? The sum of all forces, the mass of the system would be equal to 5 kilograms times its acceleration is equal to 24, technically newtons. And when you divide newtons by kilograms, you get acceleration. So acceleration would equal 24 divided by 5, which is 4.8 meters per second squared. Now, both of these blocks are moving at 4.8 meters per second squared. Not one, but both. Okay? The next one we're going to be doing is going to be on an inclined plane. And again, for inclined planes, it's important to recognize what the force of friction is, and there's a few other things happening in this one. So for starters, let's go down and match the normal force. This is the force normal, which is going to be matched and be the same as mg cosine theta, and that would be what friction would have to deal with, with the mg cosine theta, because friction is the normal force times the coefficient of friction. Now this block right here would like to go this way. That would be what it would like to do, but it's being pulled down on this side. So this block is actually going upward via the force of tension that is created by this block that is going down due to gravity. Now this is mg sine theta. Okay? So what we're having to deal with here is the sum of all forces, just like before, the sum of all forces in the system will be equal to a few different things. I'm going to run out of room, so I'm going to have to do it down here. It would be equal to, let's start with this basic block. This basic block, that is just going down due to gravity. And that block, according to it, the word problem, is 10 kilograms. So this block is 10 kilograms. Let's label it so I know. This block over here is 5 kilograms. And the angle is 30 degrees. All right. Coefficient of friction, 0.2. We'll remember that. So this 10 kilogram block is going down. That's what it wants to do. It is being stopped by the force of tension, and that force of tension has a lot involved with it. So let's start with the 10 kilogram times gravity. That's what it wants to do, but we have to take away the force of tension. And that force of tension has a lot dealing with it. That force of tension has A, the friction of the block, and B, how much this block would have liked to have gone downward, but can't because it's being pulled upward because of the force of tension in the opposite direction for it. So we would have the force of tension would be its willingness and want to go down the ramp instead. We have to subtract that and the force of friction that is acting upon it. So let's start with 10 times 10 minus what it would like to do, mg sine theta, go down the ramp this direction. Keep redrawing the arrow so it's almost invisible now. That way. It would like to go that way, down the ramp, mg sine theta. And we would also have to subtract the force of friction that is counteracting it as well, which would be the normal force of this block, which would be mg cosine theta times the coefficient of friction. So we'll call that chem k times cosine theta. I forgot my mg, so times m times g. All right? And that whole thing is subtracted. All right, well, let's fill in some values. We got m, we know the mass of this block is 5. So we got 100, 10 times 10 is 100, minus 5 times 10 for gravity, sine of 30 degrees, minus the friction coefficient, that would be 0.2, cosine of 30, times the mass, times 10. And now all we have to do is do some calculations. Let's see what that all equals. I got 100 minus 5 times minus, I didn't hit the minus button, minus 5 times 10 times sine of 30 minus 0.2. I'm using a calculator. 0.2, now I covered up my problem. Times cosine of 30 times 5 times 10. And I get a syntax error. There we go. Fixed syntax error. We get 66.397. I hope that is right. After having an issue with my syntax error. Well, let's see if it is. All right. So that would equal the sum of all forces in the system is equal to 66.339 newtons. That's not the question. The question is find the acceleration of the system. Well, remember, these things are attached, so they are going to be accelerating at the exact same speed. So that means mass times the acceleration of the entire system would equal 66.339. And the mass of the entire system would be both of these blocks combined. The system is everything. That's why it uses the sigma for sum. So that would be 10 and 5 put together, better known as 15, equals 66.339. If we divide 66.339 by 15, you get your acceleration of the system is equal to 4.42 meters per second squared. All right, that's going to do it for this one. Until next time, everybody, stay positive, and I will see everybody later. Bye.